All right. So today we're going to talk about the chain rule via tree diagram, which I find to be the enjoyable way to do the chain rule. So I'm sure you're kind of looking at the chain rule in the book, and there's like a type one, there's like a type two. It's kind of hard to sort out. I think this is the easy way to remember things. So the case that I'm looking at, just for example wise, is I've got a function f that's a function of three variables x, y, and z. And then each of x, y, and z is a function of three more variables, r, s, and t. So if I'm thinking, okay, man, that's like a lot of stuff to keep track of, here's what I'm going to do. I'm going to make myself a little tree. So I'm going to put f up top, and f's going to depend on three things. So those three things are x and y and z. And then x depends on r, depends on s, depends on t. Y depends on r, depends on s, and also depends on t. Oh, oops, that's not a t. Jeez, yeah. And then z depends on r, depends on s, also depends on t. So it's pretty easy to conjure up. If you have different variables or more variables or less variables or whatever, you just write down all the dependencies. There's nothing to it. You just do it. Then you need to conjure up what goes along each of these little edges. So because f depends on three things, everything here is going to be a partial. So I'm going to have partial f with respect to x, right? So that's this end on top, this end on bottom. And actually, I'm going to switch that whole thing to pink. Which pink do you think that is? I think it's that one. Okay, so there's partial f with respect to x. That's this arrow here. This middle arrow is going to be the partial of f with respect to y. Oops, that pen got a little heavier. Oh. And then this one's going to be the partial of f with respect to z. So those are my three top level arrows. Now each of these lower arrows, so x depends on three things. So these are also going to be partials. So this is going to be the partial of f with respect to r, partial of x with respect, sorry, did I say f here? Partial of x with respect to r. This one's going to be partial of x with respect to s, partial x with respect to x, partial x with respect to t, partial y with respect to r. You guys get the idea, right? So jot them all down. Partial y with respect to s, partial y with respect to t. I thought this video was going to be quick, but I didn't think about how long it was going to take me to write these down. Partial of z with respect to r, partial of z with respect to s, and partial of z with respect to t. Now, if I had a variable that only depended on one other variable, I would use hard derivatives instead of the soft ones. Whatevs, you got it. So now our total here is going to be like, okay, maybe I want to think about something like df dr, right? So that means that I'm going to go look for the r's. I go bam, 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 r's. And I'm going to say, okay, so the way to get from f's to r's is going to be I could take the x route. So I could do partial of f with respect to x. There's a partial of x with respect to r. That's check there, that path, right? Then we could add to that partial of f with respect to y times the partial of y with respect to r. That's this guy, check, right? And then there's our last one of partial of f with respect to z times the partial of z with respect to r, right? Cool, there we go. That's all the green ones, right? Now, if we wanted to do a different one, like we wanted to do partial of f with respect to s, well, now I'm looking for s's. So I'm going to say there's s's all down here. And I'm just going to check off the paths by which I can get to an s. So that's going to be the partial of f with respect to x times the partial of x with respect to s, plus the same thing for y's. So partial f with respect to y, partial y with respect to s. And same thing for z's. So partial f with respect to z, partial z with respect to s. That's it. We could write the third one down, just kind of checking paths off. You'll notice that these top ones get checked off a lot. The other ones get checked off less often. Ultimately here I should end up with 3 check marks on the top paths and 1 each on the bottoms. Yeah. This little diagram approach keeps things straight. It means that you're a little bit less likely to lose one if you've got something complicated. If you're evaluating the point, you can put values down in these. It's relatively doable. I think this thought helps. It's not crucial to understanding. So if this isn't the way you want to think about chain rule, that's totally fine. You can just like try to keep track of all the ways things change, and that's totally fine. It works. I like these though, so if you want to use them, go for it. Thanks.